Hello, math students. Today we are focusing on a new topic called Absolute Value Inequalities Part 1. And I want you to know that we're just focusing today on greater than. So the inequalities that are going to be greater than. And notice in parentheses I have here greater. Greater sounds like greater. So this or is going to come into play a little bit later because we learned the other day with our compound inequalities that the ors always go out. The ands go in and the ors go out. So there's going to be something about shading out in this lesson. Okay, so let's take a look at example 1. Example 1 says solve. What are we solving? Well, we're solving this absolute value inequality. It says the absolute value of x is greater than 4. So we need to think of, let's go down here, what numbers could replace this x? Let's think of some numbers that if we took their absolute value, if we took their distance from 0, that distance would be more than 4 units from 0. So think about it. I'm going to kind of do like a Blue's Clues thing here. Think about it. What could it be? I don't know what you're thinking, but I know that if you're thinking 5 will work. The absolute value of 5 is 5, and 5 is bigger than 4, so 5 works. Maybe you're thinking 6. The absolute value of 6 is 6, and that's bigger than 4. Maybe you're thinking 7, maybe you're thinking 8, maybe you're thinking 9. Those all work. Maybe you're thinking 4.1. 4.1 is greater than 4. So all these numbers are numbers that are bigger than 4. So numbers that are bigger than 4, I mean, even like 4.1, I could put it down here. So 4.1, 5, 6, 7, 8. All these numbers that could replace x are like over here near 4, but they're not 4. They're bigger than 4. So they're out here. Now the reason I put this empty circle on 4 is because I don't want to include 4. If I try to plug 4 right here, I would have the absolute value of 4 is greater than 4. I know that the absolute value of 4 is itself, and that unfortunately is not a true statement. 4 is not bigger than 4. It's equal to, but it's not greater than. So that's why the empty circle is there. Okay, so is that it? I mean, do we have any other numbers whose distance from 0 is more than 4? What about -5, -6, -7, -8, -9? Are those numbers more than 4 away from 0? Well, sure they are. The absolute value of -5, if I put -5 here, I get 5, and 5 is bigger than 4. -6, the absolute value is 6, and 6 is bigger than 4. So I also have solutions to this inequality all down here to the left of -4. So if you think about it, let's take a look at this. So here's 0. Here's the magical number when you're dealing with absolute value. None of these numbers are more than 4 away from 0. None of these are. These are less than 4 away. But everything beyond that 4, everything beyond it, all those numbers are more than 4 away from 0. Same thing over here. These do not work. These numbers in here are not more than 4 away, but everything behind it is. These are all more than 4. So if I'm trying to put this into words, like if I try to take this absolute value inequality and put it into words, I would be looking for numbers. X represents numbers. So maybe I say numbers that are more than, I'm going to capitalize that, more than, because that's my greater than. Numbers that are more than 4 units away from 0. And I think I've modeled that right here. Where I have shaded this number line, all of these numbers are more than 4 away. So my solution, so let's come down to our final answer here. If I read the different inequalities here, I have 2 different inequalities. They are going out. We can't be 2 different places at once, hence the or coming in, greater. So I'm going to put the or in here or here. And these inequalities are going to look like this. This side is x numbers bigger than 4. That's this side. Or this side, numbers less than negative 4. That is the solution to this problem. Okay, now this is the meaning. Okay, so I just showed you the meaning, which is the most important thing. But I can give you a trick. And we've already done this in class, so I'm going to say our little jingle, our commercial jingle. When you see the bars, and there they are. When you see the bars, you may think that it's bizarre, but it's not. Just bring it down. So see, I brought it down. I dropped the bars when I brought it down, but there's the x greater than 4. Bring it down and flip. See the flip? I changed this symbol, less than. I flipped it. I also flipped the sign on the 4 to negative 4. So you're flipping these 2 things if you're doing the jingle. So when you see the bars, you may think that it's bizarre, but it's not. Just bring it down and flip. So it works for our inequalities just like it did for our equations. You might be thinking, Ms. Callahan, why then, when we did problems like this, like when we did absolute value of x equals 4, when we did those, we brought it down, yes, and we flipped, yes, but we didn't flip that symbol. Well, we sort of did. What happens when you take an equal sign and you flip it around 180 degrees? You still have an equal sign. So you can think about it the same way. You're still bringing it down and flipping. It's just you're flipping both of these, both of these, both of these. Whatever's not inside the bars is what you're flipping. So you're flipping that and you're flipping that. Got it? Awesome. Let's go to the next one. Example 2. Solve. The absolute value of x is greater than or equal to 2. Okay, so let's think about what numbers could replace x. Well, I actually think 2. This time 2 could work because it's got the equal to bar on it. The absolute value of 2 is equal to 2, so that'll work. So will 3. 3 is greater than or equal to 2. 4, 5, ... So like all these over here are working. 2 and out. 2 and greater. All these numbers have a distance that is more than or equal to 2 away. More than or equal to 2 away. Likewise, negative 2, negative 3, negative 4, negative 5, all of those. So everything from here on left, those are all more than, see, more than or equal to 2 away from 0 on the number line. Nothing in here is going to work. These aren't far away enough. They got to be more than 2 away in either direction from 0. So in words, we're looking for numbers that are 2 or more. So 2's included. That's why I filled these dots in. Numbers that are 2 or more units away from 0. Okay. So now let's go to our solution. Well, what do these 2 inequalities say? Let's start over here. Well, this says numbers greater than or equal to 2, or this says numbers less than or equal to negative 2. So we're going this direction or we're going this direction. Jingle. When you see the bars, you may think that it's bizarre, but it's not. Just bring it down and flip. Okay, we brought it down, we flipped. What did we flip? Both this went 180, turned over, this changed to a negative. Flip. Okay, flip it to the back. Flip it to the back. We got 2 more problems to go and we're done. So example 3 says, solve the absolute value of 2x minus 3 is greater than or equal to 5. Now, when you get here, it's a little bit harder to see what values of x are going to make this true. See, it was easy on this side because just a single x was inside the bars, but now we got x tangled up with a 2 and a -3, and it makes it more difficult to figure out. I mean, I could sit here and play with it. Like, if I let x be, I don't know, 10. If I stick 10 right there for x, then I'm going to have, what do I have? The absolute value of 2 times 10 minus 3 is greater than or equal to 5. I think that's going to work because 20 take away 3 is 17. And the absolute value of 17 is 17. And that is greater than or equal to 5. So like 10 works, but I don't want to sit here all day guessing and checking. That could take me a really long time. So let's take a look at the words and see if we can't translate a solution here. So in words, I'm thinking 2x minus 3. So all that stuff that's inside the bars, whatever that is, 2x minus 3 is 5 or more units away from 0. 2x minus 3 is going to be 5 or more units away from 0. So if I look at my number line, 2x minus 3 can float over here 5 or more this way. So 2x minus 3 can kind of float here. Or if it's more than 5 away, it can kind of float down here. See how it can be here or here? It's more than or equal to 5 away from the magic 0. So it can't be in here. It's got to be further this way, and it's got to be further that way. So that sets up my two inequalities for my solution. So like my 2x minus 3 can be this way, greater than or equal to 5, or my 2x minus 3 can be less than or equal to my -5, which is down here. That's the meaning. Now do the jingle. When you see the bars, you may think that it's bizarre, but it's not. Just bring it down and flip. So here we brought it down. Here we flipped this symbol to here, and we flipped 5 to -5. Okay, so now we just solve algebraically. So if we're solving this for x, we add 3, cross those out, 2x less than or equal to -2, divide, x is less than or equal to -1. That's one part of my solution. Or, here I add 3, 2x greater than or equal to 8, divide and divide, x is greater than or equal to 4. Okay, now look at remember up here when I was playing around and I guessed that x was 10 and I said, yeah, that works. Well, look, numbers that are greater than or equal to 4, since this is what x can be, see that 10 would be in here. 10 is in that realm. 10 is greater than or equal to 4. That's why 10 worked. So the only values that would be able to go in for that x up there and make this whole thing true are numbers less than or equal to -1 or numbers greater than or equal to 4. Anything you pick on those intervals will work. Anything not in those intervals will not work. And our last example, example 4. Oh boy, this has Uncle Joe and some cousins and some friends and brothers and sisters with it, so we're going to have to do some rearranging here. 2 absolute value of 4 minus 2z minus 3 is greater than 15. So you know what's got to happen here. We cannot do anything until the bars are alone. So let's get rid of Uncle Joe. Let's add 3. That gives us 2 times absolute value of 4 minus 2z is greater than 18. Now, we are never, ever allowed to distribute into absolute value bars, so don't even think about it. These aren't parentheses. So since this 2 out here is being multiplied to the absolute value, we'll get rid of it with division. 2 divided by 2 strikes out to 1. Now I have the absolute value 4 minus 2z is greater than 9. Okay, now that I have my absolute value bars alone, I can go to my words. So this stuff in here, 4 minus 2z, that is more than 9 units away from 0. So 4 minus 2z is going to float, but it's going to float more than 9 units away. So here's 0. So if I'm more than 9 units away, I got to be out here and further out, not equal to 9, greater than 9. Or I can float back here. So this is where 4 minus 2z can kind of float based on translating this into words. So let's set those inequalities up. So this side is telling me that 4 minus 2z is bigger than 9, or this side is telling me that 4 minus 2z is less than negative 9. So you see, we brought it down and we flipped, bring it down and flip, these two, flip. Now we just solve it. So here we're going to subtract 4. Negative 2z is less than negative 13. Divide by negative 2. And z, do you remember the rule? When you divide an inequality on both sides by a negative, he flips again. And that's going to be 6.5. So our z values must be more than 6.5, or, same thing over here, subtract your 4. Negative 2z greater than 5. Divide, divide. Flip it, z is less than negative 2.5. Okay, so these are the values, anything, numbers that are bigger than 6.5 or numbers that are less than negative 2.5, they're the values of z that if you come all the way back to the top, fill them in, the left side will be greater than the right side. So hopefully this made sense. Great or, all ors, or. When your problem starts off originally as greater than, it's a great or, and you know you're going out. You got to be more than so many units from 0, which pushes you out. All right, thanks for watching.